Hey there, Free Science Tutor here, and today we're doing a video on arithmetic sequences. So this is the lesson overview. So we're going to go over what is an arithmetic sequence, showing a sequence is arithmetic, the general term formula, and how to find a specific term within a sequence, and then a few example questions just to bring the 3 points above together. So we're going to start off with what is an arithmetic sequence. So arithmetic sequence, the way you've got to think about it is there's got to be a common difference, this common difference D here. So it's a sequence in which each term differs from the previous term by the same fixed number. So if we look at this example here, we've got 2, 4, 6, 8, and 10, and you can see that each next term differs by plus 2 from the term before. It's a 2 plus 2 is 4, plus 2 is 6, plus 2 is 8, and plus 2 is 10. And the key thing to notice here is they can also be negative common differences. So here we have 2, 0, minus 2, minus 4, minus 6, which we have a common difference D of minus 2. So here we have D is 2, and here we have D is minus 2. So now, showing that a sequence is arithmetic is something you're often asked in exams, and it's just a basic thing that can help you in more complicated questions. So all you have to do to show that a sequence is arithmetic is show that you have a common difference D, as we mentioned in the question before. So if we look at this sequence here that we've been given, all we have to do is take two terms. So let's take these two. So 21 minus 7, that will be the common difference there. Let's take these two. 35 minus 21, that will be the common difference there. And then let's take these two. 49 minus 35 is the common difference there. And finally this one here. So 63 minus 49 is your common difference. Now if we just pop that, you get a common difference of 14, 14 again, and you get the gist of it. So by doing those common differences and showing that D is equal to a fixed number, you can show that it is an arithmetic sequence. So now on to the general term formula. It might look a bit complicated at first, but don't worry, it's not too bad. So first you have Tn, which is term number. So the way to think about this is, let's say you want to work out the 10th term in the sequence. That little n below the t here, that would be 10. So if you're working out the 10th sequence, it'd be T10 equals T1 plus n minus 1d. T1 is just the first term of the sequence. So if we look at the example above quickly, the first term would be 7. So T1 would be 7. N minus 1 is linked to the number, the term number you're looking at again. So if you're looking at the 10th term, obviously that n would be, you insert 10 into there. And d is the common difference that I've been going on about all for the last two parts. A really important thing to note here is that the coefficient of d, which is n minus 1, is 1 less than the term number. So a lot of people make the mistake of putting this as n and forget it's n minus 1. So here, remember this is n minus 1, really important. Okay, so if we look at this example here, so we have a question. So if you want to quickly pause it and have a try yourself, and then I'll go through it. So let's go through it now. So we've got a sequence. It says find a formula for the general term Tn. So if you remember, there's a few things we need. So let's just write out the general form of the general term formula. So it's Tn equals T1 plus n minus 1 d. So things we need to know for the general term formula are d, T1, and n is just, you don't need to know that because obviously it alters depending on which term you're looking for. So if we look at the sequence we've been given, we can instantly find out what T1 is, which is the first term here, which will be 7. And the common difference, we just quickly do a few calculations. So you do 21 minus 7, 35 minus 21, 49 minus 35, and you should find they'll all equal 14. Yep, there we go. So that's that. So D is 14. So the formula for the general term is Tn equals 7 plus n minus 1 times 14. Now, the part B says find the 100th term of the sequence. So it's very simple. Now we've done the hard work, all you need to do is put n as 100 because it's the 100th term. So here we put T100 equals 7 plus 100 minus 1 times 14, which is obviously 7 plus 99 times 14. Quickly pop that into my calculator. 7 plus 29 times 14, which equals 1,393. That's that for that section. Now let's go on to some example questions. Okay, on to this example. So it says find k given that 3k plus 1, k and minus 3 are consecutive terms of arithmetic sequence. So instantly you should notice this. It says it's an arithmetic sequence, which means there's going to be a common difference d. So just quickly note that down. Common difference d. Now let's just write the sequence out. 3k plus 1, k minus 3. You might be thinking there's all these k's, how am I going to know find k? So let's just look at before how we did it. So here we had an arithmetic sequence and we found the common difference between each one to show that it was an arithmetic sequence. So we found the common difference was 14 between the 21 and 7, 35 and 21, and 49 and 35. So all we're going to do is exactly the same and showing that the common differences are equal, because we already know that it's an arithmetic sequence. So all we have to do is show that this difference here is the same as this difference here, which means k minus 3k plus 1 equals minus 3 minus k, which means k minus 3k minus 1 equals minus 3 minus k, minus 2k minus 1 equals minus 3 minus k. Then we can bring this over here, minus k equals minus 2, so k is equal to 2. On to example 2. So pause it as before if you want, and then you can join back and I'll go through it straight away. So find the general term Tn for an arithmetic sequence with T3 equals 8 and T8 equals minus 17. So this is an example of a more complicated question that you might be asked, where you have to use simultaneous equations as well. So if we write out the general formula again, so Tn equals T1 plus n minus 1 times d. So basically what we're going to do is fill these in for this. So we know it's T3, so we put T3, which equals 8, right? So we do 8 is equal to T1 plus, and we know n, right? N here is equal to 3 for this one, based from here. N is equal to 3. So equals 2, I'll just write it like this for now, times d, which means 8 is equal to T1 plus 2d. Now if we look at this one over here, n is equal to 8, so T8 is equal to minus 17, so minus 17 is equal to T1, which is unknown at the moment, plus 8 minus 1 times d, which means minus 17 is equal to T1 plus 7d. So now we have two simultaneous equations, right? We have one here, and we have one here. So we need to just solve the simultaneous equations. If your exam board allows you calculator papers, obviously you can just put these in your calculator and you can find the two constants, but I'm just going to do it fully just because obviously some boards don't allow calculators in the exams. So if we just write these next to each other, a equals T1 plus 2d, and minus 17 equals T1 plus 7d. So here we can see the T1s. If we just minus one from the other, we'll get rid of them. So let's call this A and this B. So if we do B minus A, so it's minus 25, which is obviously minus 17 minus 8, equals, that will get rid, T1 minus T1 is 0, and that will be 5D. So that from here we can find out that D is minus 1 over 5. Sorry, what am I on about? Minus 25 over 5, which is minus 5. Then all we have to do is sub this back into one of these original equations. So here we have 8 is equal to T1 plus 2 times minus 5, which we've just worked out is D. So 8 is equal to T1 plus minus 10, which is just minus 10. So T1 is equal to 18. So when we put this back in our original equation from here, so let's take this down here. Get it bigger for you. So we have Tn equals T1 we found is 18 plus n minus 1, and we've worked out D is minus 5 here. So we just write minus 5. Now sometimes people like to write it out fully, so you could expand this. So you could put Tn is equal to 18 minus 5n plus 5, which obviously is 23 minus 5n. Now we're going to go on to the final question. So insert 4 numbers between 3 and 12 so that all 6 numbers are in an arithmetic sequence. So as I said before, as soon as you see this word arithmetic sequence, you want to know there's a common difference D. Just write that out. There we go. Then, so let's write this out. So it'd be 3 plus D, the second term would be, because you're just adding the common difference. 3 plus 2D, 3 plus 3D, 3 plus 4D, and that's 1, 2, 3, 4, 5. And then we have the 12 at the end. So it shows that all 6 numbers in an arithmetic sequence. So if you look at this, this is essentially, if we follow the sequence from before, 3 plus 5D. So that we can establish that 3 plus 5D is equal to 12, which means that 5D is equal to 9, which means that D is equal to 9 over 5, which is 1.8 because 1 4/5. So now, does it ask us to, so it says insert the 4 numbers. Now you have to work out what the 4 numbers are just by inserting this, D equals 1.8, back into our original sequence that we formulated. So we put 3 plus 1.8 is 4.8, 3 plus 2 times 1.8 is, so I put a plus there, 6.6, 8.4, 10.2, and then 12 at the end. So I hope you found this video useful, and yeah, comment. I hope you enjoyed the video, and let me know in the comment section if there's any topics you want me to go over, and please leave a like and subscribe if you can. Thank you very much.